Okay, this is lesson 1.1, and it's about the number of solutions to a linear system. First things first, what is a linear system? Well, a linear system is a set of two or more linear equations. So we have three sets of linear systems in our example that we're going to explore. We have linear system with line A and B, a second system with C and D, and a third system with E and F. And when you have a linear system, you can look at the solution to a linear system. And a solution is just the point or points where all equations are equal. So that would be like setting the equations equal and solving and finding a solution, or on a graph, it would be where the lines cross. So if you ever see the wording, find the solution to the linear system, it's asking you to find the point of intersection. And we've done this already in our review unit by graphing. We graph both lines and look for where they cross. This lesson is not about how to graph lines. We covered that already. This lesson is about all the different ways that lines can interact on the Cartesian plane and form solutions. So the question I want you to think about before we get started here is, how many different solutions do you think are possible when you graph two lines on the same Cartesian plane? So that means when we graph two lines, I'll give you one example. We could have a line that goes like this, and a line that goes like this, and we would have one point of intersection. So therefore, there's one solution. And the solution is whatever the coordinates of that point are. So this question is about how many different ways can we have solutions? Well, one type is where it crosses exactly one time. So if you'd like, you could pause the video and think about this question before we do the lesson, but we're going to investigate this concept a little bit further. So in order to investigate, I've got three systems here. We're going to graph the three systems separately, and we're going to look at how the lines behave. So the first pair is system A and B. So line A is already written in y equals mx plus b format, which is kind of nice, because when we're in y equals mx plus b format, the number on the end is the y-intercept. So if I was going to graph this line, I would start at the point 0, -2 on the y-axis, the y-intercept. And then I'd use my slope to find more points. This slope is just the number 2. Well, slope is rise over run. So if I wanted to rewrite this number 2 as a rise over run, I would write it as the fraction 2 over 1, because 2 divided by 1 is 2. So that means from our y-intercept -2, we have a rise of 2 and a run of 1. So I'm going to do that on my graph. I'm going to go up 1, 2, and I'm going to go over 1, and I'm going to draw another dot. Once you have two dots, you have enough to draw a line. So I'm going to take my two dots, and I use a ruler, connect them, and I'm going to draw a line. And this line, with arrows on the end, represents equation A. I'm going to do the same thing for equation B, and we're going to look at how these lines behave on the Cartesian plane. We have a little bit of a problem with equation B. If you look at equation B, it's not written in y equals mx plus b form. So we have two options. As we looked at graphing lines, you could find the x and y intercepts, graph those 2 points, and connect them, or we could rearrange the equation and make it look like y equals mx plus b. I'm going to do the last method. I'm going to rearrange this equation. So our goal is to get y by itself. If y is negative in our equation, I usually move it to the other side to make it positive. It makes the isolating a little bit easier, because now we have 2y equals 4x plus 8. That's by adding 2y to both sides. We get rid of the negative 2y, or take the negative across the equal sign and turn it positive. Either way you want to think about it, we end up with this equation. We want to say y equals, right now it says 2y equals. So if we divide both sides by 2, we get 4 divided by 2 is 2, and 8 divided by 2 is 4, we get 2x plus 4 equals y. If I want to flip it around and write it the other way, we don't have to change any signs if we're changing both sides of the equation. We get y equals 2x plus 4. So to graph this line, we're going to take a similar approach now. The last number, plus 4, is my y-intercept. So starting at 4 on the y-axis. And 2 is my slope. So that's again the 2 over 1. So I'm going to go up 2, 1, 2, over 1, draw a point. And I've got another dot. 2 dots is enough to draw a line. So I'm going to take my 2 dots and a ruler, connect them, and I'm going to draw a line. Now, if we take a look at line B, what's the solution to our linear system? Well, those lines don't actually cross on the Cartesian plane. So the question is, will they ever cross? And the answer is no, they won't ever cross. And the reason why they won't ever cross is because, well, both lines have the same slope. So if they haven't crossed and they keep going up and over by the same amount, both lines up and over by the same amount, they're never going to touch because they're going to keep increasing at the same rate. So this is a type of solution, even though the answer is there's no solution. This is a no solution linear system. So the question is, how do we know that this is going to be no solution without making the graph? Well, the key is to compare the equations. If you look at both equations after we rearrange them, look at what they have in common. Both equations have the exact same slope. Equation A has a slope of 2, and equation B, once we rearrange it, also has a slope of 2. So the property that no solution has in common is that both lines have the same slope. Now, two lines with the same slope have a special name: parallel. If you have parallel lines, that is, if you have lines with the same slope, you won't get a solution to that linear system because they'll never cross. All right, let's look at our second system. Our second system is y equals negative 3x minus 2 for our first line, and the second line is 2x minus half y minus 1 equals 0. Well, our first equation again is in y equals mx plus b format, and since we're getting pretty good at graphing lines, we're going to go through this one a little bit quicker. The y-intercept on the end is negative 2, so we start at negative 2, and our slope is negative 3. Well, I'm going to rewrite that slope. That would be negative 3 over 1. So that means down 3, right 1. So from this dot, 1, 2, 3 down, right 1 to get a second dot. That's our slope. So 2 dots, we can connect them with our ruler. So we've got 3 over 1. See if I get this one right here. And there's line C. Line D is going to be a little bit trickier, because again, it's not in y equals mx plus b form. So we need to take our equation, 2x minus half y minus 1 equals 0, and rearrange it. And again, since our y is negative, I'm going to move that term to the other side. That half you might be a little intimidated by. Don't worry about it. It's just like a number. It stays with the letter. The question is, how do we get rid of that number? Well, when we had 2y, we divided the 2 away to isolate for y. We could again divide the half away and isolate for y, but then we get like 2 divided by a half and negative 1 divided by a half, and that might be a little tricky. What we can do instead is, since it's 1/2, if we multiply both sides by 2, half times 2 is 1, so that half would go away. So we're going to actually multiply both sides by 2. We're going to take this side, we're going to multiply it by 2. We're going to take this side, we're going to multiply it by 2. And what we end up with is y on the right side, and 2 times 2x is 4x, and 2 times negative 1 is negative 2. That x there might be a little confusing. It's not the same as this x. It just means multiply. So we end up with 4x minus 2 equals y. If I rewrite it, we got y equals 4x minus 2. So now we're going to graph our equation y equals 4x minus 2. So start at our y-intercept negative 2. A slope of 4 means a rise of 4 and a run of 1. So starting at negative 2, we're going to go up 1, 2, 3, 4, over 1. We got another dot. Use our 2 dots to draw a line. That's our equation D. And this time, we have an intercept. There's a shared point of intersection, and that's 0, negative 2. So this time we have a POI. And that point of intersection is 0, negative 2. Remember, read x first, then y. And this type of solution is just called one solution. And the property here is that when you have one solution, you are going to, I misspelled parallel, just noticed. When you have one solution, you're going to intersect at a point. And the key here is that you have different slopes. If you ever have different slopes, you will intersect somewhere. If you graph the lines and it doesn't cross on your graph, it just means it's going to cross eventually somewhere off your graph, assuming they have different slopes. So if we go look here at the slopes of our two equations, our first one was negative 3. And our second slope was 4. So we have different slopes, negative 3 and positive 4. When we have different slopes, the lines will cross once. So you might be thinking, what's the last type of solution? Well, they either don't cross or they do cross. Like, how else can there be a solution? Or a different type of solution? Well, there is another scenario. That's our lines E and F. E and F. Let's graph E first. So starting at a y-intercept of 1, we have a slope of negative 4, so that's down 4. 1, 2, 3, 4 over 1. We get our first line. And if I draw my line through those two dots, that's line E. And our second equation says 12x plus 3y minus 3 equals 0. That's not y equals mx plus b form, so I'm going to rearrange it. This time our y turns positive. So I'm going to keep it where it is. I'm going to move the other terms over. 12x to the other side would become negative 12x. Negative 3 to the other side would become plus 3. And we've still got plus 3y. To get rid of the 3 in front of the y, divide both sides by 3. Leaves us with just y. Negative 12x divided by 3 is negative 4x. And 3 divided by 3 is 1. So we end up with the equation y equals 4x, negative 4x plus 1. And if we compare that to equation E, you might notice that we have the exact same equation. We have two lines that when we rearrange the other one and make it look like the first one, they actually look the exact same. So if I go to graph this line, I'm just going to end up graphing it right over top of the other line. So to show that, you just put a second set of arrows on the ends of both lines, and then we can say that that's E and F. So what's this called? Well, when you have two lines that are the same equation, they cross at every single point. So that's called an infinite number of solutions. And that occurs when you have the same line. How do we know we have the same line? Well, we have same slope and the same y-intercept. So let's go compare really quickly. Do we have the same slopes? Well, we have negative 4 in front of our x term in our first equation. We rearranged the other equation and got negative 4. So we do have the same slope. Do we have the same y-intercept? Well, plus 1, plus 1. We have the same slope, same y-intercept. So that means we have the same line, and that means we have an infinite number of solutions. So everywhere on that graph that the line exists, they cross because they're the same. They're on top of each other. They're called concurrent. And that's actually it for our first lesson. So what do we need to be able to do? Well, from an equation like this, we need to be able to rearrange it, make them both look like y equals mx plus b, and then from the equations, we should be able to now tell how many solutions we're going to have. If they have the same slope and the same y-intercept, we're going to have an infinite number of solutions. If we have different slopes, we're only going to have one solution. And if we have the same slope but different y-intercepts, no solution. And we can show that by graphing, but now that we know those three properties, we don't necessarily need to graph them. We can just look at the equations. So that's it for lesson 1.1. Thanks for watching, and I'll see you next time.